So far, we were concerned about calculating derivatives. So if somebody would give us a function, so f, we want to calculate its derivative. This operation is called differentiation. Today we're going to talk about the inverse operation, and that is when somebody gives us actually a derivative of a function and asks us to find the actual function that produced this derivative. Such operation is called integration. So let's start with a simple example. Let's say my derivative is 2t. All right. And I'm asking you what function produced that derivative. Well, you can say, well, I know that. I watched the video about power functions, and I know that the function t squared give us that derivative. And you'll be right. That yes, t squared, if you differentiate t squared, you get to t. But then if somebody else come and can look at this and say, well, what about a function like this? T squared plus 3. Well, if you differentiate this again, you also get to t. When somebody else comes, he says, well, what about t squared minus square root of 2? Well, derivative of this function is also 2t. So now you probably understand that if you have t squared plus arbitrary constant c, any constant you want, it will give us 2t as a derivative. So when we had a function and we wanted to find a derivative, we pretty much had a unique answer. But when somebody gives us derivative, it looks like there are, well, actually infinitely many answers. So by knowing the derivative, we actually have some uncertainty when it comes to actual function. But now the question is, how big is this uncertainty? Is it just a constant that we need to add? Or it's something more sinister, some kind of function that could be constant sometimes, but there's also some other function that also gonna give us the derivative as 2t. And let's talk about it now. Let's say we have a function f that produces derivative of f prime. We also have a function g that produces derivative g prime. It turned out to be equals to f prime at all points of all t. And now we look at the function h, that is difference between these two functions. So what we're really trying to do, we're trying to find how much difference this f and g could have. And h tells us how much there is. All right. So what we'll do, we just calculate derivative of h. And if you watch previous videos, you know that h prime is equals f prime minus g prime. But f prime equals to g prime, so this is 0 everywhere. So now we're looking for a function h, which derivative is 0 everywhere. Well, if you remember, we talked about the meaning of the derivative. We said the meaning of the derivative is a rate of change of a function. Well, if a rate of your change of a function is 0, it means the function does not change. It means this h is constant. It could be any constant you want, but it's a constant. So what it really means that when somebody gives you a function, well, somebody gives you a derivative of a function, f prime, the way to find all the possible options for the function that produced this derivative is to guess about one function f that produce that derivative. And then you simply say that all the functions, if you're interested in all the functions that can produce that derivative f prime, those functions are represented by that function f plus an arbitrary constant. And that's it. There's no other functions that could produce that derivative. So, and that's actually helps us a lot. So let's go back to our example. We said that f prime equals 2t. And then we found one function f that produced that derivative, and that was t squared. So now we can say that all functions that produce this derivative to t are that one function we found, t squared, plus an arbitrary constant. And there's no any other functions that could produce this derivative. All right? So let's consider another example. What if I have, f prime equals 3t squared? Well, you say, well, I know one function that produces this as derivative, and that is t cubed. But when I'm talking about any other function that can produce, overall, all the functions that can produce this derivative, those functions can be represented as that t cubed plus an arbitrary constant. All right, in the next video, we're going to talk about more complicated examples. See you then.